All right, so thank you guys for coming to this programming camp. Hopefully you guys will learn something. And so we're going to start off with just a bit of an overview of the week and just basically our agenda on what we're going to do. So for Monday today, we're going to be going over what an SDK is, what is an op mode, and as well as some like basic Java stuff, so like variables, conditionals, methods. And then after that, once you guys have a good understanding, we're going to be going over what the autonomous op mode outline looks like in a Java program. And then we're going to talk about the steps to writing an actual op mode, which includes declaring your hardware mapping, and then how you actually control your motors. And then we'll also be doing a demonstration of that. And you guys can also follow along if you'd like. Okay, Tuesday.
So for Tuesday, what we're going to be doing is talking about the encoders and the actual movement of the robot. So the first thing we're going to be talking about is the mechanism drive. So the concept, as you guys might know, mechanism drive is moving, just basically strafing, so having the robot move left and right. So it's a pretty interesting concept, and you can't understand it very easily. So we're going to go over that in detail with the concept, the forces, and the math behind it. And then the next part of that, we're going to be doing is using encoders. So we're going to be talking about how to use them, how they work, the formula for how the ticks and the revolutions all work together, the encoder methods, learning how to use the mechanism drive strafe with the encoders, and then explaining how they all interact with each other. So that's what we're going to be doing for majority of Tuesday.
All right, cool. So Wednesday, as you guys saw in our flyer, we are going to be going over some detection. So this camp we'll be using OpenCV, and we're just going to be talking about like what OpenCV is, why we want to use it in FTC, and some benefits over TensorFlow or Vuforia. And then we're going to talk about how to actually install the Easy OpenCV library for FTC. And once you guys have that done, we will go over a OpenCV pipeline structure. So that's basically how the actual detector is set up and how you can, do some color detection, edge detection, that type of stuff. Then we'll be talking about the basic OpenCV variables and methods. So you guys will learn what a variable and method is shortly today, and we'll be able to apply that with OpenCV. Then we'll talk about some ways you can actually do your detection, and then we'll finally create an actual detector that you can use on your starter stack.
So finally, on Friday, we're going to try to actually create an autonomous program, setting you up for the future, which you're going to have to make an autonomous program on your own. And the way we most likely will be doing this is through MyBot Simulator. And if we won't have time for this, then we'll give you the software, and then you can use that software to make your own autonomous.
Yeah, sounds good.
So yeah, before we get started, we can introduce ourselves and talk about how the camp's going to run on logistics. So I'll start off. Hi, I'm Nikhil, and this is my 4th year in FTC, and I'm a programmer for team Sub-Zero 18275.
All right. So my name is Nihar. I'm another instructor for you guys. I've been programming for the past 3 years, and I'm a programmer on FTC team 18275.
So I'm Ishan, and I am also another instructor, and I've been in FTC for 3 years and am the programmer for 8719 Quantum Leap.
So before we get started, just some logistics. So you guys all have access to the Camp Virtual Hub, obviously, because that's how you got here. So if you have any questions, just please put it in the chat if you feel like you might interrupt. And if no one's talking, just feel free to use your mic and ask us what you need. And if you guys have any questions that need a lot of help, just text us, just put it in the chat, and you guys can just move to help session 1, and one of us will be able to help you. So that's going to be kind of how it works this week. And if you have a question that you really want to have answered through person, just use the raise hand on Google Meet, and we'll be happy to stop and answer your questions.
Yeah, so actually, Nikhil, do you want to put the links for help session 1 and 2 in the chat? So if anybody wants to get on it, they can just click it right there.
Yeah, I can put that.
All right, so let's get started. So as we talked about today, we're going to be going over the introduction to the FTC SDK. So starting off with what an SDK is. So basically, an SDK is a software development kit. So it's basically all of the code that you need to actually get started writing code for some sort of application. So in this application, it's FTC, and you're going to be writing code to control robots. So for example, you don't want to actually write the code to control a DC motor with the hardware, right? Because that's pretty advanced and that's really deep. And that's what you want the SDK to take care of. But what you do want to control is things like setting your power to your motors, um, controlling the motors using a gamepad. You want to take care of that stuff. But you don't want to do the stuff that goes on in the background. And that's what the SDK is for. So it basically takes care of all of the um, behind the scenes stuff. And the reason why we actually use an SDK compared to another form of compiled code is because we are actually using Android Studio and we're deploying code to an application on the Android devices, which you guys should have on your expansion hub, or if you just or you might have just a driver station for your control hub. And SDKs are commonly used with app development, and that's kind of why we use it, since we're deploying code to an actual Android device. Okay.
So what is an op mode? So you might have heard op mode in the FTC programming video. So an op mode stands for operational mode, and it's basically a framework that was developed by FTC to help ease the creation of programming that communicate to the hardware very easily. And the two types of op modes in FTC are the autonomous op modes and the teleop op modes. And if you use the tag at the top, which we'll show you later on, then you can basically make it so that it shows up in different places in the app. So your autonomous would show up in a different place than your teleop op modes.
Yeah, so just remember, an autonomous op mode is a program where the robot functions on its own without a gamepad. And a teleop op mode is basically where you can control the robot using your gamepads. All right, so now we're going to be going over some basic Java. So it's important that you guys understand the basics of the Java programming language before we actually start teaching you guys how you can control your robot, because it's pretty much needed, because of course we are using Java. And the things that we're going to go over is variables, data types, conditionals, and methods. So this is actually this is pretty basic Java, but it should be enough to get you set up with programming a simple op mode. Okay, so starting off with variables. So I'm assuming most of you guys have passed basic algebra, or maybe even algebra 1 or 2. So you should know that a variable is basically holding some sort of data. So I like to think about it as like a bucket for a data type. So as you guys see right here, we have a bunch of variables in this block of code. So when you're actually declaring a variable, you have a data type, name, and then the value associated with it. So for example, this variable is called mynum right here. The data type is int, which is an integer or a whole number. And then you're setting the value to 5. So another way to think about this is if you have two buckets. One of them could be a red bucket and one of them could be a blue bucket. So the blue bucket you can think of as a data type as blue, and only blue objects are allowed in that blue bucket, just like these variables. So this int only allows integer values. This string only allows string values in it. And we'll be going over more data types in the next slide, but this is pretty much just how you want to use basic variables. So different applications of it could be storing the amount of ticks per revolution or any constant values. So you could have, so if you have your X and Y position of your robot, you can store that position in an integer variable. And another useful part of variables is that you can actually change the values throughout the program. So at one point, my num could be 5. And later in the program, that value can actually change to 10. And then it can change to 0. So it can change throughout the program. And that goes for all of these different data types here. And then another part, just to remember, is whatever is on the right side of a variable is actually being set to the left side. So this 5 is being set to my num. This true value is being set to my bool. And for example, you can actually set another variable's value equal to the variable on the left-hand side. So that kind of takes the same case where whatever's on the right side is being set to the left side. And you're using this equal sign to signify that something is being set. Okay, so
we talked about the variables, and what you probably saw in the previous slide is that the variables were actually defined by a type. Now Nihar talked about how blue buckets can only store blue items, and then red buckets can only store red items. So that's kind of what the data types are basically showing. Data types are, you can change, or you can put specific data types on your variables, and those data types would hold different things. And in Java specifically, you have to put a data type. So some of the primitive data types are integers, doubles, floats, and booleans and characters, which is noted as char. An integer is any like whole number. A double is a decimal value that's really long and it can hold a lot of decimals. A float is a decimal number that can't hold as many decimal values, and it's a little bit more inconvenient because you have to put an F after it. So usually in FTC, we use doubles, but technically floats are more efficient because they use less memory. Booleans are true or false, and then characters are specific letters and stuff that you can find on your keyboard. So they can be like period, exclamation point, any letter like W, X, Y, Z, or they can be like the slash or something. Now, something that's not a primitive data type, but is still widely used in Java is a string. A string is basically a combination of multiple characters smushed together into one word or sentence. And that's what's shown in here. Some examples of strings can be hello world, banana, or I love coding. So yeah.
Yeah, so before we move on, so let's just go back to the slide before. So as you notice, certain variables with data types have different things that are actually telling Java what data type you are using. So for example, we have this F right here for float. If you have this F right here, it's telling Java that you are setting a float value. For this character variable right here, we see this one quotation around the D. That's basically just telling Java that you're using a character. And then for this string right here, we have these quotation marks, or these double quotes. And that is just telling Java again that you're using a string. So if you didn't have these quotation marks, Java would probably throw an error because it doesn't understand what type of value you're giving it. So that's pretty important. So let me actually show you guys an Android Studio of us creating a couple variables. So I just have this test class open. You guys don't have to follow along. We'll just show you guys a couple examples here. So if we want to define a variable called height, so we can create, so height would probably be in inches, and usually you want to put that in a whole number. So we're going to use the int data type. So we can call that height, and we can set that to, let's do 60. So your height is equal to 60. And you can consider that 60 inches if you want to. And this is the first time that we've actually defined the variable. And that's why we have this int right here. So we didn't talk about this before, but when you actually are creating the variable, that's when you have to tell Java which data type you're giving it. Later on in the program, if I want to reuse this variable or change the value of it, we can do something like height, or we don't actually have to, put the actual data type in front of it. So we can just do height equals 1.
Wait, can I just interrupt you really quick? So the reason why we're not actually putting the data type there is because when you're putting the data type, that's basically telling the program that you're creating the variable. However, we're not creating the variable anymore. If we did create the variable, then it would most likely give us an error because we have two variables of the same name and type. However, so that because of that, we can just use the same variable that we have already. We do not need to create another variable. So when you say int, then you're basically telling the program, I'm going to create a new variable here, specifically a integer type.
Yeah, that's a good explanation of it. So now we can, if you want to do a double, so this is the first time we're creating this variable. So we can, we have to put the data type in front of the variable name. And we can just call this, it's a real life object that requires a decimal. We can just actually, let's just call this decimal. And then we can set this to 1.0. So with doubles and floats, it's most commonly to always include a decimal point, even if it's a whole number. So if I was just keeping that to 60, I would have to have a 60.0. Right there. Oops. 60.0, like that. And then if you want to change the value, we can just call that decimal. We can just refer to that decimal variable again, and we can set it to maybe 102 point bunch of random numbers. So those are just a couple of variables. And yeah.
Wait, Nihar, show them. Actually, we're primarily going to be using doubles and strings. I think, or doubles and okay, never mind.
Okay. Yeah. So there are a couple of data types which are still used, like string, booleans. So booleans are just true and false. There's no other value they can be besides, of course, like uninstantiated, or they're just set to nothing. So yeah.
Oh yeah. Also, do you guys have any questions, or are you understanding so far?
Yeah. If you, yeah.
I understand. I'm having a good time.
All right, cool.
If you guys have any questions about anything, just please drop it in the chat. We'll definitely, address them. So just if you guys are confused on anything, if we're going a little too fast.
Mm-hmm.
All right. So next is conditionals. So basically a conditional it's kind of self-explanatory. It basically just allows certain code to be ran if a condition has been met. So this is the actual syntax, or how you write a conditional, and this is an if statement. You call it an if statement since it has an if right here, and this is saying if 20 is greater than 18, run this code. So the code that you're running inside of the if statement, if the condition is met, is actually inside of these two curly braces, and we like to call these code blocks, or just blocks of code. So you'll often see curly braces signifying a block of code. Just that's something to remember, because you'll see it in a lot of different places, like methods, method bodies, classes, all that stuff. So this is saying if 20 is greater than 18, then run this code. Since this condition is true, it will actually run this code. So if this condition was not met, so if it was saying like if 18 is greater than 20, then run this code, then that code would actually not be run. And you can do the same. You can actually put different things in these parentheses, which is, you can just think of that the place, you can think of the parentheses as a place where you put the condition. So you can do things like, you can check if a Boolean is set to true. So you might have a Boolean called button pressed, and you can set that to false at the beginning of your program. And if that Boolean is true, then you will run a certain code. And for example, like if you're in teleop and you want to do like if the button A is pressed, then move some servo, you might have an if statement that says like if button is pressed, and that could be a variable. And if so, you can do like if button is pressed equal true, then servo dot set position whatever. So that's just an example. So we'll go into more depth about moving motors, servos, all that stuff later, but just think about it like that if you want a real life application. So there's different ways you can actually compare things to see if conditions have been met. So of course we have the standard less than greater sign, or less than equals greater than sign, that type of stuff. And then we have this equals equals. So basically what that means is you're checking if the actual value of the variable or whatever is equal to something.
Yeah, so I like to explain it like this. So like if you just put a single equals, that's saying that's telling the program to set the variable equal to something. However, if you're putting two equals, you're asking, is this equal to XYZ variable, whatever.
Yeah, that's good.
And then the exclamation point and then equals to is the exact opposite. It's saying, is this not equal to? Yeah.
Yeah. So most of the time, you're probably going to be using some sort of variables in this condition, or in these parentheses to specify a condition, and you'll probably be using some sort of operators like these.
Okay, let's move on.
Okay.
So
All right.
methods or also called functions can basically call or execute a certain lines of code multiple times. So you don't have to actually copy and paste and copy and paste and copy and paste your code. You can encapsulate that entire like 5 or 10 lines into a method, and then that method will return something. So it's if you ever learned, like in math class, you might have learned like the function boxes. So they're basically like a box, and then you plug in these values, and then it does some magic, and then it outputs something. That's it. That's exactly what a method does. So you can call this box, and then you pass in some values. It does its magic or its code, and then it outputs a value. Now, sometimes it doesn't output a value, and that's when it would be called void. So the functions normally include passing statements, so parameters, that it basically asks the user to pass in those values into the box or the function. And then it has a return statement. So that's exactly what it's going to return. So it's kind of like a cycle like that. So you can call these methods multiple times in your program, and that's why it's very significant, because it can make your code a lot less, it's a lot more simpler for you to read, especially during like competition time, when you have to like read through like 1,000 lines of code, and you need to know exactly like one thing to fix. If you called a method like 7 times, you don't have to change it in every single location of that method call. If you change it once in the method, then it'll change everywhere else in your program. And that's one of the reasons why object-oriented programming, which is the use of methods and objects, is very useful in FTC. Yeah, you can go to the next slide. Oh, Nihar.
Oops, sorry, I was muted. So just going over like what call means. I know Ishan like talked about that a little bit, but basically just calling means that you're executing a function. That's just a way that programmers like to say it, or that's a programming term. And then so just a real life example in FTC could be having a method to turn to an angle, and you can pass in a angle. So that could be like an integer, 45 degrees, for example. And if you pass in the parameter, which is 45 degrees, the code inside of the method will execute using that variable. So you're passing that variable, it'll do something with that variable, and it'll and that something might be turning a robot.
Yeah. So also, I think in the next few slides, we're going to be going over some examples of this. And then after those slides, we're going to be creating one, and then you can follow along with us. And that'll give you a stronger understanding of how this works. So Nihar, can you go to the next slide?
Yeah.
And actually, when we use methods, we actually use them a lot in like autonomous programming. So like when you're talking about encoders, in order to have like a straight, that itself is a method because it varies in code than from a like a forward backwards method. So tomorrow we will be using methods a lot as well. So make sure you understand them.
So basically, this is an example of method. So you'd have again the void, which is telling you what you're actually returning. So that can change into anything. That can change into a integer. It can change into a double. It's basically whatever you are returning. And
So
like I said earlier, if you have the function box and then you do your own code and everything, you have to return something, which is that's the type that you're returning, not the name of the variable that you're returning, but the type. So that's and then the next thing that you have is the name of the function. So here we're just making a simple adding one function where you just add one onto a variable that already exists. So that's the name of our function. And every time that we want to call that function, we would literally just type in add one, at least if it's in the same class, which for the purposes of this camp, we will be working in the same class. So yeah, and then after that you have parentheses. Now these parentheses are very important. I've seen a lot of people miss that and they start to like just skip the parentheses. However, that's going to cause errors, and also you won't be able to put parameters. And parameters are basically the inputs for your function. So in going back to the function box, you usually have to input something here. Actually, let me pull up. Hold on. Oh, never mind. I can't share. Okay, whatever. So in a function box, you usually input something into the function box, and then that outputs something. So the inputs are what we're calling parameters. And that's just a common programming term. So,
so in this method that we're defining, there's actually no parameters, as you see. So parameters would actually go in these parentheses. So you'll be seeing that in the next slide where we show a couple more examples. But this is a void function, so there's going to be no return type. So it's literally just going to add 1 to x. That's all it does. So you can we'll show you guys how to actually execute these methods in the next slides, but this is how you guys are going to define the method. So you're basically saying what do you want, what do I want this method to actually do, and what is the name of it, what is the return type, just basic characteristics about it. And as I mentioned before, the curly braces signify a block of code. So anything inside of these curly braces will be it'll be relevant to this actual method right here. So we have this opening curly brace and closing curly brace. So anything inside of it.
and actually, that's one of the things that most people actually miss when they're learning Java, because if they're coming from like other languages, you don't usually have those curly brackets. However, in Java, it's very important that you put those curly brackets, or else it will not know like where the function starts or where the function ends. So it's so yeah. And then finally, the code that you actually want to execute would be in the middle of those two curly brackets.
Yeah.
As you can see here, we have a couple. Yeah, you can go to the next slide. As you can see in this slide, we have a couple more lines of code to execute. Starting off with the top, we have an integer instead of a void. That's the first thing that you can notice, because the reason why is because we're actually returning something in this function. So we're taking an input, we're doing our little code and everything, and then we're actually outputting something. And that output is going to be an integer this time. And then we have our function name, which is add. And if we want to call this function, then we are going to just do add. We're just going to say add in the program and then put the parameters. So we're going to call in the inputs. And here, the parameters or the inputs is x and y. And they're both integer types. So whenever you're passing or whenever you're creating parameters for the function, you always want to create or you always want to tell the data type. It's almost like creating a variable. You always want to put the data type and the variable. That way, the programmer will know how to, what kind of variable they're supposed to put in there. Now, you're going to have the curly brackets once again to signify the start and end of the function. And so inside where you have like the actual code is int value equals x plus y. So basically what this means is earlier we talked about the creation of variables. Here we are creating a variable called value. And this variable is the data type integer. And the value is going to be equal to x plus y. That's all you're doing. You're taking the input x and you're adding that with the input y. And then the next line, you can see that you are returning a value. Now, if you go to the previous slide, Nihar, you can see that we didn't actually return anything. And that's the reason why we put a void. And if you go back to the next slide, you can see that we are now returning something. And that's why we're putting the int over there, because we are returning an integer value. That way, the user will know that they can basically mess around with that value once they actually get it. So that's basically what return does. Return is just saying, now we're done with the actual logic of the method, and we're just going to return the variable value. And the variable value is in the line right above that, the one that we created. So
Yeah.
Before I move on, I just want to make sure that if anybody has any questions, you can either tell me or ask us right now, because that was pretty confusing. How will we be able to be returned a value? So that will come up soon when we call
So actually, yeah, let's go to the next slide. That's a good question. So how do we actually use the value that we've returned? And so let's just see this add function right here. So we've defined this add method, and we later in the program, or actually above where you want to actually call it, you might have a variable called final val, and we're defining a variable right here, and we're setting it equal to, so we're setting the value to the output of this method. So we have this add method, we're passing in the parameters 1 and 5. And since the value equals the first parameter plus the second parameter, we know that this value will equal 6. Sorry, yeah, 6. Then we'll return this value back, and it'll go to this variable. Oops. Yeah, so it'll go to this variable right here. So later on, if we want to use this final val, it'll be equal to 6. So often when we're using methods with return types, you'll be setting it to some sort of variable, and that variable has to be, again, the same data type as the actual return type of that method, or whatever the method is returning. And so this is an example of calling a method. Again, so this is executing your method. So we've defined it in the previous slides. Defining the methods. And then how you call it is you write the name, you have 2 parentheses, and in the parentheses, you're going to pass in whatever you need to pass in. So since add1 didn't have any parameters or a return type, we literally just keep this parentheses empty, and then we just put a semicolon, which just means that end of line or end of the statement. So in Java, we like to just use these semicolons, similarly to how you might use a period in like English. It's just telling the program that you've finished the line or finished the statement. So another place where you'll be using methods, besides just purely in like these cases, are methods like these. So these are actually going to be instantiated on objects. So you don't need to worry about that right now, but let's just look at what's after this motor dot. So we have this set power parentheses 0.5. So it looks pretty familiar, right? So similarly to how we have this add 1, 5, we're calling this set power function. And this set power function is asking for a double value. So you want to pass in, or as your parameters, you want to pass in a double. So we have this 0.5, which we're passing in. And what this method will do, as the name says, is it's going to set power to a motor. So just a little recap of methods. So they're basically just functions, and you can recall functions whenever you want or execute them. And it pretty much just it makes your code much easier to read as well as much easier to write. You don't want to be writing a ton of code even like this. If you're repeatedly going to use the add method, or instead of just doing this x plus y thing, you can just call this method right here. And methods can actually be super huge, just like the set power. Set power is probably a pretty large function considering it actually has to interact with the motor hardware and all that stuff. You don't want to be rewriting that code every single time you want to set power. You just want to write the single line and pass in the power that you want to do, that you want to set. So let's actually do some examples of methods. So let me just create a method down here. And what do you want to call it, Ishan? What should we call this?
Power, because we're going to be doing that soon anyway.
Set power. Okay. So we can have this as a void. Set power. So parentheses. And then let's ask for a double power. So we're just going to call the variable that the parameter is passed in as power. And then we have these two parentheses, or these two curly braces.
Just add, or just make like a variable called power and then just set it to power temporarily.
Okay. Double power equals power.
Make the other one.
Yeah, I'll just call this my power. So what this is doing is taking in whatever input you're giving. So it's going to be double power. So you can have this as like, again, 0.5. And this power, your parameter is going to be stored in this variable called power. And we're going to we're going to reference this variable and set that to my power. So going back to variables, whatever's on the right side is going to be set to the left side. So this power, this parameter you've passed in is going to be set to my power. So let's call this method. So how you call again is you write the name, set power, pass in, and yeah, that should work, but looks like there's an error. Okay, so as you noticed, so we're not going to go over public static right now because these are actually called modifiers and keywords. And that kind of, yeah, it's slightly advanced, so we're not going to go over that right now, but just know that this is a defining a method. So we're having the set power method, and then it's asking for the parameter of power. So we're going to be passing in 0.5, which is the power. And then it's going to be setting it to this my power variable. And yeah, that's it. So what if we want to do something?
Now try a return.
Return, oh yeah. So let's change this void to double. Double set power. Now what we can do is, now you see it's erroring, right? Because it's missing a return statement. So what we can do is we can do return my power. So we're returning this variable which has been set to something, and that variable is going to be set to power. So of course, we don't want to lose the return. So like, since there's no variable this is being set to, it's just going to like, the value is just going to be thrown away. So what you want to do is, let's just create like another variable called double final power. and that will be set to the value of set power. So that'll be set to the return. So my power, that's going to be returned to this final power function. And let's actually figure out, or let's print the actual value of final power now. So let's just run the system.out.println function, and don't look at the system.out for now. This print line is basically another method, and this is a method created by Java. It's used to print data out to the console or to the terminal. So let's just pass in the final power variable. So again, we're using a method and we're passing in some sort of data. So what it should do finally is print out the value into my terminal. So let's actually run this. Let's see. Okay, looks like it's like compiling right now. Let's wait for that to happen. If you guys want to take the time to actually write out a method right now, I encourage you guys to open up like Android Studio and going into your team code package right here. So Java team code, and you can right click, create a new class, call it whatever you want, and you guys can just practice creating methods. After today's camp or today's lesson, you guys can practice this on your own and try to do some just try to make whatever methods you like. So you can make an addition method, you can make a subtraction method, just anything that you just want to play around with. So it looks like this is gonna like take too long, so I'll just stop that. We can test that later. Right. Right. So Ishan, do you want to talk about that math analogy with like f of x with methods?
Yeah, so basically what we did was make a set power function, which it really wasn't a set power function. It was just called set power. Where in the future, we're going to be loading that up with a bunch of code to actually set the power. But this is very similar to a function in algebra. So in algebra, you would say f of x, or in other cases, you would do g of x or g of y. So that tells you the input parameters. And then if you put g of x, then the function is actually called g, but the parameters would be x. So it's very similar. You can name it whatever you want, and then inside the parentheses, you would put your parameters. So that's basically the function thing. You can move on to the next topic, Nihar.
All right.
So far, I don't think there's any.
Hold on, yeah. All right. Also, do you guys have any questions about methods, variables, or data types? I know we went a little bit fast on that, but if you guys want us to clear up anything, feel free to write it in the chat or maybe unmute your microphone.
Personally, I don't have any questions. I think you guys are doing a great job.
Thank you. If anybody else was a little unclear with anything, just let us know right now. Or we can move on.
Yeah, because these concepts, they go through like all of programming. Like you're gonna be using these all the time, so make sure you guys understand the basics. Because from here we just like add different things to it. So make sure you guys are able to understand like method and conditionals and things like that.
Personally, when I was starting programming, like methods were kind of confusing to me because I wasn't past algebra or algebra 1, so it was a pretty confusing concept to me until I actually started writing it on my own and asking questions to actually clear up things, and they became pretty easy for me to understand, and I just started using them a lot in my FTC code. So All right, so if not, we can move on to op mode structure. So Ishan, would you like to go over that?
Yeah, so we talked about methods, and the op mode structure is basically a framework built by FTC to make it easier for you guys to start programming and get started and actually learn the important parts about robotics. And in the op mode structure, there are two main functions that you have to instantiate or have to create, or else it will cause errors. And these two functions are init and loop. So first, going over the init loop. The init loop runs only once, and it runs when you click the init button. And it basically, you can put any initialization code to initialize variables or even hardware. So you can initialize servos to certain positions, and it will only run once. So make sure you don't put like a loop in there, because there's another function for that. But these are the two main ones that you have to make, or else it won't work. So then you have the loop function that actually runs in a loop. It doesn't look like it runs in a loop, but these functions, you don't have to call them. Like we said earlier, you usually have to call these functions, and they are being called. It's just not in a place where you can see them. They're being called by FTC somewhere else. So don't worry about it being called, because they are being called, and they are being called in like FTC's in the background of their code. So then you have a function which runs in a loop. So it iterates like over and over and over again. That's what a loop means. So a loop basically runs over and over and over again. And one of the most common mistakes is that people forget this. People forget that it runs over and over again, and they write code in a way that it only runs iteratively. So it runs one after the other and then like that. However, it's important to note that you can't just like tell the motor to set power in one line and then set power to another value in another line, because it's running in a loop. So it's going through both lines, and then it's running again in a loop. So it's going to start causing stuff to jitter. So that's probably one of the most important things to understand, that the loop function actually runs in a loop. So as soon as you click start, that's when the loop method starts running. So those are like the two most important functions to the op mode structure. And to actually to actually make a class part of the op mode structure and use their framework, you basically have to extend to op mode, which I think it's in the next slide, right, Nihar?
No, not yet. But we can.
Well,
Here, hold on.
you can also
Yeah, let's
show
just.
it.
Yeah, I'll just show it. But let's just.
Yeah.
I just want to like make sure you guys understand. So what you're doing here is you're writing a function body. So we're defining the init function. So currently it's empty, and the loop function is currently empty as well. And once you have code written in it and you run your op mode on your phone, each button you press, so like the init button, when you press the init button, that will literally execute this init function. So again, you're not going to be calling it like this. So you're not going to be like calling it in your code anywhere. It'll be called by the phone. So it'll be executed by the phone. And all you're doing is writing the body of the method. So when you have an op mode, these methods are going to be empty. So it's going to do nothing when you run your program. That's why we actually have to put some code inside of these. So then when they call, when the phones and FTC calls the methods, it can actually do something. And this init method runs when the init button is pressed. It runs once, and then this loop method runs in a loop after the start or triangle button is pressed. Okay, so let's go to Android Studio, and I can create a new class. So hey, Ishan. All right, so I'm gonna create a new class right here. Let's call this we can call this autonomous. All right, actually let's call this test op. Test op. Okay. So the first thing that you do when you create an op mode or a class is if you want it to show up on your phones and you want it to be an actual op mode and run some sort of code for a robot, you want to do this thing called extend extends op mode. So there's actually two types of op modes. There's linear op mode and there's regular op mode. So for the sake of camp, we're going to be going over regular op mode. So linear op mode, the difference is that it just runs in a different way. So it has different methods, and it has different methods that you're actually writing the function bodies of, and just runs in a different way. So let's just extend op mode, and it's gonna throw a bunch of errors like this with the squiggly line, and what you want to do is hover over it and click implement methods. So as you can see, it's going to be adding this init and loop.
Yeah. Also, I just want to mention. Wait, can you click cancel really quick? I think it's useful if you like type it out yourself. Nihar.
Okay.
Useful for them.
So public void.
So this is like the function structure that we were talking about earlier. So you type in public and then void, saying that it does not return anything, and then init. Now you have to put at override because you're telling FTC, the program that FTC wrote, you're telling them that you're giving them access to override your function. So basically, they're going to be calling your function by because they have some background code, and if you put at override, then you're basically telling them, here, you can call my function. You can call it wherever you need to. And the way that you know that it's being called is because, as you can see, it's yellow. So Nihar, can you write like a random other function that doesn't matter?
Okay.
So the way that I do it is, as you can see, Nihar put a function called do nothing. And as you can see, since it's not being called right now, it's actually gray. So that's a good indicator that that's not being called. And the way that I look at it is that one is yellow. So that means that it's being called by FTC somewhere in their background code. And if like just if you accidentally spell init wrong, like put a capital I or something. So now Nihar accidentally spelled init wrong. So you get two indicators. First off, the at override is red, and then second off, the init is gray. Now the third indicator is that you have a red in the test op. So like in the public class test op extends op mode. So it's again saying that you did not create the init function. So now put that back to the right spelling, and now you know that I have done this correctly, and I can move.
Yep. Cool. So I just want to ask a question. So what types of things do you think might go in the init function body? So what types of things in your program would you want to do what type of things would you want to do in your program to run once? And that one time would be only when you click the init button on the phones.
So yeah, that's a good point. So the init, and also another thing that you would put in the init body is initialization of variables, so that you make sure that they're not null. Any hardware initializations, which we're going to go over soon, and also just initializing anything on your robot, which is anything like servos and oh wait, you were asking.
Yeah, I was asking them. It's all right.
Okay. All right. But yeah, anything like any hardware initializations like servos and stuff, you can initialize there.
Okay. Yeah, so I guess we already went over that. So for loop, like Yishan mentioned before, that's just basically what you're gonna like what the code or it's gonna be things like moving your robot during autonomous. Like it's gonna be like stuff like driving 10 inches. It's gonna be things like setting power to your motors based on your gamepad. So things like that. That would go in loop, and it's gonna be running continuously throughout your program. The init stuff is only going to be have run once. So for example, like hardware mapping, which we'll go into more. Hardware mapping, you don't want to be continuously mapping your motors throughout the program, because that's just, first of all, wasting memory, and it doesn't need to be done like 2 million times. You only need it to happen once, and that's during the init period. All right. So, oh shoot, what is this? Okay.
Also, somebody brought up in the chat like a good point. The init and loop are, if you guys know anything about Arduino, then it's very similar to the init and loop in Arduino. Or I think it's called
Okay.
star.
Shoot, what is this? Okay, hold on. Okay, whatever. Okay, let me just present again. Okay. Right, so now we've gone over what the op mode structure looks like. So basically the things that, like the skeleton of an op mode. Let's go over how to actually write, or the steps that you need to actually, have your robot move, do all that stuff. So first of all, the first thing that you want to do is declaring your op mode members. So these can be things like variables, hardware mapping, your hardware variables, all of that stuff. So that's going to go at the top of your program. Next, you want to do something called hardware mapping, and we did go over that a little bit before. But hardware mapping is basically how you tell your hardware variables which hardware to interact with on your actual control hub, expansion hub, or on your robot. So, for example, we might have something called motor 1, and motor 1 is currently set to null. So that means it has no value right now. Then when you hardware map it, you're actually telling motor 1 which motor on your robot you want that to correspond to. And then you're able to do things like motor 1.set power, and you can do something like have that motor move to or be set at a certain power. So yep.
Okay.
All right, and then you have the code running after the play button is pressed. So of course, actually, let me just ask a question. Where does the code go that happens after the play button has been pressed?
In the loop method?
Yep, that's correct. So it's in the loop method. So that loop method is going to be running continuously after the play or start button has been pressed. And yeah, so you can do things like moving your robot forward, interacting with the gamepad input, that type of stuff. All right, so Ishan? Ishan? You want to go ahead? All right.
Yeah.
Okay.
So declaring op mode members. So op mode, so we call member data as like variables that are initialized outside of functions. So that would be like outside of the init and loop, there would be like, wait, am I really laggy right now?
Not your microphone.
No, you're doing fine. Yeah.
Yeah, you're fine.
So the member data are these variables that are instantiated outside of the init and loop functions. So these can be because one of the common mistakes that I've seen is that people put the variable creation inside the init. And the problem with that is that you can't access it inside the loop if you created it in init. Variables that are created in init can only be accessed in the init function. However, if you put them outside, then you can access them in both init and both in loop. And these are called member datas. This is called member data because it can be it's these variables that belong to the class, the op mode, and you can use them anywhere in the op mode. So some examples of these are motors, because you use them both in the init and you use them in the loop. So here you can see that we created some variables. So left drive motor and right drive motor. And the type would be DC motor because that is the class that allows you to basically set powers and do a bunch of stuff with DC motors. So The reason why Nihar put it to null was because in the beginning, he just instantiates it to null temporarily. However, in init, you actually put in a value. Null simply means nothing. So if you put it to null, that just means you're leaving it empty. You're just saying, I'm just going to leave this variable empty. However, in the init, you actually fill that up with the hardware mapping details, which we'll go into soon. But for now, we're just declaring op mode members.
Mm-hmm. Yep.
For now, yeah. Nihar,
So
if you want.
here, let me just go over something really quickly. So as you see, we're creating this variable called left drive motor, right drive motor, and like before, we use these primitive data types. So data types created by Java, such as int, double, float, boolean. So those are primitive data types, again, created by Java. So DC motor is actually a data type, but DC motor has not been created by Java. It's actually been created by FTC, and hence we use a SDK. So the SDK provides this DC motor data type that we can use. And for example, integers, you can do things like add other integers together. You can do different things with integers. With DC motor data types, you can do things like setting power. You can do things like connecting them up with your actual motors or with your physical hardware, which we'll do with hardware mapping. And there's different classes that the SDK actually provides, such as servo. So servo would be another data type that has been created by FTC. And again, you can do different things with the servo, such as set the position of it. And then we see this other variable here. It's of the data type double. That's a primitive data type, and we're just storing the ticks per revolution, which is an encoder constant which you need to do some calculations for. And we've just had it in this little block of code. And we're setting it to 537.6. And another word for data types that are not primitive is a user-defined data type. So you can actually create your own data type if you want to for different uses. So that's more of an advanced concept for like object-oriented programming. So you guys won't be doing that right now, but it's good to know for the future.
Right. Okay. Well, I mean, also, I think that a user-defined data type isn't is something else, but yeah, it's this is something. This is called like a class. If you guys want to ever research into it, it's called yeah, it's called a class. But you just basically create an object of a class. That's what we're basically doing here. But for now, just think of it as a data type. So,
yeah. Just so these are just motor variables right here of the type DC motor, and then we have this double variable. Okay, so moving on to hardware mapping. So as we see, we have this hardware mapping in the init function. So in the init function body. So we don't want to do hardware mapping. We don't want it to happen continuously throughout the loop or throughout the program, because that's, like I mentioned, like it's kind of useless and it just wastes data in memory. So we want it to only happen once. And as we see, we are referring to this left drive motor again. So remember, we're not creating it, so we don't need to have this data type in front of it. We're referring to the left drive motor, and we're setting it equal to hardwaremap.get. So don't look at this hardwaremap.dot part, just look at the get. So get is again a function since it has these, or a method since it has these two parentheses, and you're actually passing in two parameters into it. So the first parameter you're passing in is going to be the class or data type. So it needs to know which type of hardware you're actually mapping it. So this is a DC motor, so you're passing in DC motor.class. So that's just something to remember. So we split up the two parameters by a comma, and then we pass in the actual name of the motor. And that is going to be the name that you have on your phone configuration for Control Hub or for your expansion hub. And Ishan, how do you do it for Control Hub?
So for Control Hub, you basically have a Well, actually, you can just create the config. You still create the configuration on the driver station instead, but you can also create the configuration on the app, which they provide you. I'm pretty sure, I think.
Okay,
But
yeah.
yeah.
So on the apps on your phone, when you configure different motors, like this port, the name of whatever's in this port, that's going to be the name that you put right here. So we know this is a string because it has these two quotation marks. So it's going to use the string and do something with it. And then again with this write drive motor, since it was null before, it was set to empty. Now we're actually giving it some data, which is the actual hardware mapping information. So we have hardware map.get. Since it's again a DC motor, we pass in the DC motor.class. We're telling it, okay, the hardware data type or the hardware class we're using is DC motor. And then the device name is port 2 motor. So this could be anything. This could be like FL, FR for like abbreviations of your motors, you know? So just anything like that. And then again, this is in the init function body. Before we go ahead, do you guys have any questions about op mode members or hardware mapping of any sort?
I don't think so. I think we're good.
All right. Anybody else? Please tell us if we're moving too fast or anything. Just
Hey, one question here.
yeah.
I know you can have like a separate hardware initiation class.
Yeah, so yeah, that's true. So just for the sake of this camp, we're going to be doing all of our hardware, or we're going to be declaring all of these variables in the same op mode. So basically what Luca is referring to is you can actually do something called so you can make your code more object oriented. So that is a more advanced topic in Java, but it basically means you're modularizing all of your code. So you're putting things in different places and you're referring to them. So it makes your code much more concise and cleaner. So instead of doing all of this, these variables, instead of putting them all in your op mode where you're running all your code, you can put those in different places and just refer to them. So just again, for the sake of this camp, we're not going to go that advanced since many of you guys are pretty new to Java, and it's not required to write FTC code. Me and Nikhil, we actually didn't even use object-oriented code for a while, and it worked perfectly fine for us. So I would look into that when you guys are a little more advanced, or if you want to just find something to research, you know? So do you have any more questions about that, Luca?
No, I don't. So
Yeah, so we're not going to be doing it in this camp, but if you have any questions about that, you can email us or ask us later. All right. So now is writing code to actually make your robot move. So we've done all the initial setup stuff like your variables, hardware mapping. Now we're going to go over how to actually make your robot move. So give it to Ishan.
Okay, so these are some basic motor methods that we will go into later, but for the moment, like we're just gonna go through it and read through them. We're gonna I think Tuesday, which is tomorrow, we're gonna actually go into more detail and actually code this and get the robot to actually move. So these are some basic motor methods. So the dot set power method basically just sets the power. And again, these are methods that are part of the DC motor class. So anything you make a DC motor will be able to call this. So dot set power sets the power. Dot get current position gets the current position if you plug in the encoders, which we will talk about on Tuesday. And then dot set mode basically sets the mode of the DC motor. And the DC motor class has many modes, and some of these modes include run using encoder and run without encoders if you don't want to use encoders. But yeah, so set mode is another one. So we will today we will show you how to do a set power method, and then the next few days we're going to get into the other ones.
Yeah, so let's just let's just take a step back and talk about the set power and get current position. So set power is actually going to be a void method, and it's not going to return anything. It's just going to do some code, or it's just going to execute some code. And that code might be moving a robot with a certain set power. This get current position, on the other hand, is going to be a method with a return type, and it will return the current ticks that you have traveled. So you might want to create a variable called double ticks traveled and set it equal to your motor dot get current position, and that will basically fill up this variable with the ticks that you have traveled. So again, this is a double return type variable because it's getting something, and this is a void return type because it's setting something. And often with methods, you'll always see get and set. So we like to call them like getters and setters. So setters will do something, getters will get some data, and you can store it in some sort of variable. So this is a set mode. So similarly to this set power, it'll do something, it won't return anything. It won't return anything back to you in your program. It'll just do something on the robot, or it'll do some functionality. All right, so that should be the last slide here. We have an hour left, right, Ishan? So what we can do now is actually start writing a bit of code. So I just want to make sure, did all of you guys watch the video which we sent on how to install Android Studio and the SDK? And did you do all the installation so we can get started writing some code? If not, please type in the chat. No worries. Nikhil will go into one of the help sessions and will help you set that up if you haven't done already. Okay, so if you have not, please join help session 1. Just scroll up in the chat and join it, and Nikhil will be able to actually help you do that.
Yeah, so I'll be in help session 1, so just be there.
Yeah, so we did have some students that joined after, or joined kind of late since we had some issues with our form opening up and closing. So if that was one of you, no worries if you weren't able to set anything up because you didn't have much time. That's fine. So yeah. Anybody else? Can you just type in the chat if you have it set up? I don't want to leave anybody behind if you don't have it set up and not get any help with it.
And I'll put the link to help session 1 again for people who need it.
Mm-hmm. All right. If you guys don't want to write any code, I guess you don't have to have it set up, but like I recommend you just get it set up even if you don't want to follow along or something. But I highly recommend you guys write code alongside me so you guys can, get the experience. All right, so let's just wait till like 2:50 and then we'll see. So just again, like write in the chat if you didn't set it up. And if you didn't get it set up, please join the help session 1, which Nikhil sent in the chat, the link to get to that session.
Yeah, if you do not have it set up, please join help session 1 and Nihar will accept you.
Oh yeah, shoot, I have to accept people in that. Let me go to that.
Wait, no, I think I can accept because I'm the only one in it. So
No,
if anyone.
Yeah, but only me.
Oh, I can. Oh yeah, that's true. Here, let me do that really quickly.
Oh.
Oops, my bad.
Okay, that's okay. So.
All right, I'm just gonna leave this now.
Yeah.
Okay. Nikhil, mute yourself on.
Oh yeah.
On
sorry.
main. Okay. All right. So, for everybody else to follow along, So first thing I want you guys to do is open up Android Studio. So just navigate to your desktop or wherever it is and open it up. You should have the SDK installed if you followed the instructions of my video, or if you already have it done. Just please type in the chat yes or something if you've opened it up, and yeah, we can move on. All right. All right. So I'm assuming most of you guys have it opened up now. Just give it a couple more minutes. All right, I'll just give it 30 seconds, and we can create a new op mode and start writing a bit of code. So I can explain to you guys how you can write a simple drive forward for 5 seconds method, or drive forward for 5 seconds code, just as an autonomous code. So please follow along. So the first thing that you want to do is click on this package called team code. So packages are basically I just think of them as folders for code that you can hold code in. And what you want to do is right click on the package. So the package should be org first inspires.ftc.teamcode. Make sure that you guys are on the Android view. So there'll be this drop down thingy above. Just click Android. And if you don't see the team code, just click open this team code thingy right there. Click Java right there to open that up, and then org.firstinspires.ftc.teamcode. So now that's open, there's probably nothing in it since I'm assuming you guys have not written much code in there yet, or if it's a new project. So then what you want to do is right click, new Java class. And what you want to name the class is whatever you want the name of your op mode to be. So let's just call this drive 10 inches. Or no, not 10 inches. Drive 10 seconds. And so remember, right click, new class, call it drive 10 seconds. Now click enter. And it should create a new class for you like this. Now, let me just ask you guys a question. What do you think the first thing to do now that we have this class created is to do? What do you want to do to actually start writing? Or before that, what do you want to do to actually make this an op mode?
Initialize it.
How do you want to initialize it?
Public void and then init with the parentheses.
Okay, so that's pretty close, but that's actually one step beyond what we want to do first. The first thing you want to do is extend op mode.
Oh, somebody actually said in the chat.
Oh shoot, my bad. Extend op mode, yeah, that's correct. So extends op mode. Now you want to do what Rebecca said and do a public void init. And I did that pretty quickly, but public void init, 2 parentheses, and a opening.
Oh, also, sorry. It's very important that Nihar, can you teach them the tag at the top, the @telyop?
Oh yeah.
So if you do not do the @telyop at the very top, then it will not show up on the phone. So that could like trick some people and like get them like kind of confused on why it's not showing up on the phone. So that's very important. So here, since we're making an autonomous, you would say @autonomous. And if you're making a telyop, you would say @telyop. And then you would just put the name that you want to show up on the phone. And here, Nihar just put in drive 10 seconds, and that will be the one that shows up on the phone.
So Ishan, do you want to kind of explain like what an annotation is? Because like this is an annotation.
Yeah, so an annotation can basically tell another class well, it can basically communicate with another class very easily without actually using object-oriented programming. So this annotation can communicate with FTC's code very easily. Since we're extending to op mode, and we're running the init and loop functions, it will be looking for that annotation. And if you do not provide that annotation, then it won't put it on the phone. Now, that annotation right there will tell the FTC program that this is an autonomous program and I want it in the autonomous column. So when you actually click on the dropdown on the phone, it'll come up in the autonomous column. Now, Nihar, can you change that to a teleop?
Mm-hmm.
So all you have to do to change it to the teleop column in the dropdown would be at teleop. And then when you get that error, you can just do Alt-Enter. Just click on it and then click Alt-Enter. And then it would automatically import everything that you need for it. So you can put it back to autonomous now, but.
Right, so we have autonomous, and then we didn't really talk about override.
Wait,
Nihar. Huh?
Yeah. Before you move on, also, if you want to disable it, there's a cool feature where you don't actually have to remove this entire line of code. If you're in competition and you're stressed and you don't want to change too much, then you just do @disabled, and it will basically remove that from the list in the dropdown on the phone. So your drivers won't have to see all that garbage. Like if you have any prototypes or anything, then they can just have a clean, just teleop, autonomous, and everything. That makes it really easier on your drivers so that they don't accidentally click the wrong program. So,
yeah. So let's just actually remove the disabled, because if I were to run this code, I want it to show up on my phone. So what is an override? Like, what does this @override annotation mean, Ishan?
Okay, so the override annotation basically tells the FTC program that it's giving them permission to use your function. So as we talked about before, this function is actually being used somewhere in FTC's background code, the stuff inside the SDK that we don't have to worry about. However, to give them actual permission to use this function, and you're basically telling them override my function into your code. So you're basically telling them to run your code inside their code. And you're allowing them to call your function inside their code. And that's exactly what override does. It's basically telling them that they have the permission to run your function.
All right. Yep. So besides init, what is the other method that we need? Does anybody remember?
Oh wait, before you also move on, sorry. Also the @override thing, don't put it for your own functions. That's only going to be used for init and loop. And like if there's any other FTC functions that you're ever going to need to use, like there's also other ones like init loop and then stop, which you don't have to worry about that for this camp. But if you ever need those, they're there, just if you're wondering. But don't use @override for your own functions. That will not go well.
Yeah. So yeah, so anybody know what the other method that we need? Loop. Yep, that's correct. So we're going to do a @override telling FTC that yeah, you can call my method for me, and you can have access to it, and we can just do a public void loop. Okay, so I'll just give you guys like 30 seconds to make sure you have this written down. If you guys do have any errors, write in the chat, please. And actually, another thing, just while you guys are writing this, we're actually going to have all of our source code for this camp on GitHub. So for example, if you aren't able to come to one of the sessions, the first thing that we'll give you guys is the actual video of the meeting. The second thing we'll give you guys is the presentation, and then the third thing will be the GitHub source code. So whatever code we wrote, you'll be able to go back and actually check the code out and copy it down for yourselves and kind of understand it. All right, so can anybody write in the chat if you guys have any? Okay, looks like someone's having network connections. So, like I just mentioned before, this video will be or this presentation is being recorded. So what you can do is just kind of scrub to this section of the video and look at the code that I've written. And there's also going to be GitHub code, so you can just kind of copy that down and analyze it as well. So, yeah. Please write in the chat if you have written this code so far. Just say finished. Here, let me just keep it nicely like that. All right, so let's actually get started to writing some code, some more code here. So let me just make some more space. And let's create a couple op mode members. So let's pretend that we have a two-wheeled robot and or a two-wheeled drivetrain. So what you want to do is create you want to create the first motor, so DC motor, and we can call this left motor and set it to null. So another thing about Java is that you can actually create things called comments, and comments are basically they're lines of code, or they're not code, but they're basically things that allow you to understand your code a little better, and it doesn't actually run in the program, so the program will not look at it. It's just for you. So how you create a comment is you do 2 slashes and write whatever you want to write. So I'll just say declaring left motor, and that just tells me that I've declared a motor right here. You don't have to write commented code, but it's kind of nice in case another person on your team wants to look at the code. They have a nice idea of what you've written. So let's declare another motor. So
Oh yeah, also comments are very, very important because not only like teamwork, like Newhar was saying, but competition. It's really hard to like read code, especially like when we're new to it. We don't really know it very well. It's really hard to read it very fast. So comments in English in or any or anything can really help you because it's not code which you don't understand. It's like your the language you use.
All right, so we've declared this first motor variable, set it to nothing. Let's create another motor variable. We'll call this DC motor right motor. Oops, we'll set it to null. And remember to reduce any errors or anything, you always have to have these semicolons. Just like in English class, when you put periods after you've said a sentence or something, you want to always have a semicolon to signify that you've finished a statement. So this is like a statement of code. DC motor, we're setting this left motor and right motor to null. You want to have these. And you don't have any semicolons for method definitions, but you do want to have semicolons here. Okay, so what else do we want to do, Ishan? What else do we want to do for a 10-second drive?
You should probably put all 4 motors.
We're gonna do it 2. Let's just keep it 2 motors for.
Oh, okay.
Let's actually create a variable called double. We'll call this double power. So instead of just inputting our power as a number or as a double into our method directly, let's create a variable for it so we can easily change it up here and it'll change the code down here. So we'll call this double.
Oh wait, sorry to interrupt you. Actually in Java, when you use the capital D double,
Oh yeah,
you're
my
including
mistake.
a lot of stuff that you don't need, so you should probably do the
Yeah,
lowercase.
lowercase double. Yeah, don't.
And that goes to everyone. Make sure you change the code so it's lowercase d. It takes up less memory and it's a lot more efficient.
Yeah, but you can keep these DC motors like this, correct? You
Yeah, keep the DC motors like that. That's necessary because that's the class that FTC created. So you can't spell that wrong or else.
Yeah, so lowercase d double. Remember that. So let's just call this double robot power, and let's set that to 0.5 semicolon. So we have this variable called robot power, and it's being set to 0.5. So the next thing we want to do is write the code for the init during the init period. Does anybody know what you might put in the init loop or in the init method? Please write in the chat or unmute your microphone. What do you put in the init method? Hardware map. So Tarun says hardware map, and that is correct. So what you want to do is do your hardware mapping, which is basically, again, mapping your motor variables to the actual motors on your physical robot. So we can do a left motor. So we're referring to the left motor variable. And since we're not declaring it for the first time, we don't need to have this DC motor right here. We don't need to tell Java that it's DC motor type. It already knows that because it's defined up here. And we'll set that equal to, and we're giving it the data. So it's the hardware mapping is just giving some data to the left motor. It's returning data about the hardware. So we'll do hardware map, hardware map dot get. So we're using this get method since it's going to be used with parentheses. And what you want to put in these parentheses is, does anybody remember what parameters you need to pass into the hardware map.get function? Can anybody say one parameter that you need?
The actual name that you're gonna put in the application.
Yes, that's correct. And then someone else in the chat, Skybang, they said the motor class. So actually not the power. The power doesn't go in the hardware mapping because remember, this is all it's doing is it's just telling the program which motor or hardware on your actual robot is going to be corresponding to which variable. So the power will be set using the set power function. That's a separate method. So let's pass in the first parameter, and that's going to be DC motor dot class. So we're telling it that it's of DC motor type. Next, we want to give the motor name or device name. Let's just call this left motor. So this is assuming that the name on your phones will be called left motor. And you can actually set this name to anything, or you can set your variable to anything, but this has to always be the same name as what it is on your phone. So it could be named like previously in the slide, like it could be named like port 1 motor, but it has to be whatever's on your phone. So for our team, we like to just set the names to what the actual names of the hardware devices. So for example, we might use something like FL or BL, back left, front left, just signifying which motor it is. So we'll just call this left motor, just to keep it consistent. And then we'll do it for the right motor. So right motor equals hardware map dot get. and DC motor dot class, then the name, right motor. All right, so as you see, we initialized the motors to something. That's another way you can think about it. They're empty right here. Now we're giving them some data. We're filling the variables with the motor data. We're hardware mapping it, and that happens once during the init period. All right, so we know that we're creating a drive 10 seconds autonomous program. What do you guys think is going to go in the loop now? What do you guys think will go in the loop function? We've done the hardware mapping. What's left to actually complete this program? Yes, the set power the set power function. You need to actually write the code to set power to the motors, because nothing's happening so far. It's just stuff is happening in the background, but you won't see anything move because you haven't told the robot to do anything yet. And that's what will happen in the loop method. So going back to the slides, we will be using the set power function or method, and that is going to be instantiated on your left drive and right drive motor variables. So the easiest way to think about it is that the methods will be corresponding to these variables, and that's why you have it after, like, that's why you do like a left motor dot set power instead of just set power, because set power isn't referring to anything. But if you have it set power to left motor, then that means that, you know, some power, or that power will be set on the left motor. So let's do that. Left motor dot set power. And since we have this robot power variable up here, instead of putting 0.5, instead of passing in 0.5 as a parameter, we can just easily pass in robot power. And we know that robot power is set to 0.5, so we can just pass it in easily right there. Now, the next thing that we'll do is we've set power to one motor. Let's set power to the other motor. So do right motor dot set power as in robot power, because we want them to be running at the same speed so they can drive straight. Because if your motor powers are not, you know, if they're not the same, then it's going to do something different. If right motor was negative of 0.5, that'd be negative 0.5, then it would actually do a turning motion. It would do a tank turn. But since we want it to go forward, we'll just keep it like this. Now, it's setting power, but how does the program know to only do this set power for 10 seconds? That's when we do this thing called sleep. So we'll do a sleep. Oops, hold on.
Wait, Sean.
What?
Wait, I don't think you can do that in regular op mode.
Wait, you can't do it in op mode?
No, you have to use elapsed time and an if statement.
Okay. So
okay, so basically, you're just like your DC motor, you can create like what I call a timer, which is elapsed time. So at the top, we're gonna go to our member data and add something called an elapsed time. This is sort of like your iPhone stopwatch, where you can easily just like start the time and tell them if you want milliseconds, seconds. So he's doing it right there. So just like DC motor, we're gonna instantiate the variable timer. So elapsed time is very similar to DC motor. Timer is the name of the variable, and then you're saying new elapsed time. And then now we're gonna make a okay, so
wait, Ishan, do you want to go over why we do this new elapsed time thing? So again, we're creating a variable called elapsed time, And we're naming it timer, similarly to how we have this DC motor and we're calling it left motor. But why are we doing this new elapsed time thing right here on the right side? What does that
So
mean?
basically, timer is empty, right? Oh wait, are you asking them?
No, I'm asking you.
Okay, good. Okay. So timer is empty. So when you just make it like that, it's empty. But we have to fill it up with something. So I'm assigning a new timer or elapsed time. Or I'm assigning a new elapsed time, or in my head, I like to think of it as a stopwatch. I'm assigning a new elapsed time to the variable timer. I'm giving it a brand new elapsed time. This means that all the values are set to 0 and no timer has been started yet. It's a fresh new stopwatch, elapsed time. Now we need to start the timer. So
Wait, Ishan. So
yeah.
so DC motor, we don't have this new DC motor thing because we're not creating a new DC motor right here. We're giving it data through this hardware map.get. So I know this is slightly confusing, but once you guys learn more Java, you'll understand how this is called a constructor and how it's actually constructing a variable. But for the sake of this camp, just think about it like this. So for the timer, you're creating a new timer in the variable right here. You're giving it the data to work as a timer. But for these DC motors, you're just connecting it up with the hardware.
Does anybody
Right,
not understand that?
That is kind of confusing though. So
Yeah, if it's confusing, yeah, just tell us. We can probably explain it better.
yeah.
All right. So far, it looks like.
Yeah. I mean,
All right.
hardware are one of the few things in FTC that you actually don't have to do a new and then whatever the class name is or type.
Yeah, because the reason why is because you want to actually initialize it inside init, because that's just the way that the FTC hardware construction goes. However, for programming like software side stuff like this timer, it's not a physical timer on the robot, right? It's just a software timer. It's like a virtual timer. So you can just do it up there. You can, because you have to actually fill up the empty space. However, for the motors, we're filling up that empty space in 26 and in line 26 and 27 when we're actually doing the hardware map.get. All right, so let's move on now. So now we need to start the timer. So we're gonna start it in another function that FTC made called public void start. Now, similar to init and loop, public void start is something made by FTC that runs when you click the start button, except it does not run in a loop. It only runs once before the loop is run. So can you type in public void start?
Yeah, and so public void. So the start method is actually not required. That's why it didn't. There's no errors without having it. It's just an extra thing that you can do
if you want to.
If you want to. There's actually a couple more methods that you can add, like stop. It runs once when the robot stops, and you can do something like displaying telemetry data on your phone and things like that. But we're not going to be using that because we don't have anything to use in that method. So let's just add this public void start. First, we need to override to tell it it's a it's a FTC method that it's going to be calling itself. And then we can do timer dot start time. Is that correct?
Yep.
So this will start the timer now, and elapsed time allows us to use this method called start time.
Now, can somebody tell me why we're doing start time in the start function and not in it?
So the start function happens when the play button is clicked, but it doesn't run throughout the whole duration of your program. It only runs once.
Yeah, you know, a lot of times, like in competition, you leave your robot on init for an extended period of time, and you don't want the timer to start counting up all that time too, right? Sometimes, like people have issues with their control hub and then, or their expansion hubs or control hubs and then you have to wait there in it. So you don't want that time to be counted. You want it to start the timer as soon as you hit the start button.
Mm-hmm.
So now we can use this timer. It's going to be actually outputting a value that we can use. So if we want to know if there's 10 seconds that have passed by, you would literally just call this function, similar to timer.startTime, you would just call the function timer.get or timer.time. And then
current millis. Pretty sure it's
no, it's just time.
timer.time.
Yeah.
Right. So what do we do with this then, Ishan?
Oh, okay. So now we learned about conditionals. So since this is running in a loop, every single time it runs from the start again, I want to actually check if it has been 10 seconds yet. And when it is, then I want to set the power to 0. So let's write it in pseudocode first. This is something that is very useful. Wait, Nihar, I'm going to share my screen really quick.
Okay. Here, let me stop presenting.
So this is something that's very useful, especially when you're starting out with Java. I think it's very useful to pseudocode. So here's how we're gonna do it. So let's just say that this is the start and this is the end of the loop. And I'm gonna show that this is actually looping by going like this. Okay, and then I'm just gonna say if hold on, let me just write.
Yeah, just use a text.
If timer is equal to or is greater than or equal to 10. 10
Wouldn't it be less than or equal to, so we can check, so we can set the
Yeah,
power
yeah.
while it's less?
Yeah, I should probably do that. Wait 1 second, sorry. Okay, sorry. If timer is less than or equal to 10, then I'm going to set power to 1.0 or something. That's not right, but this is pseudocode, right?
Set
It doesn't matter if it's
power. Okay, yeah, so set power. So basically how we're gonna do this is we're gonna say while this timer, huh? Oh, you
I'm not
wanna say
done.
it? Oh, my bad.
Wait, no, I'm not done yet. So, okay, and then if it's not equal to 10 or, so you can also say or else. So if the timer is less than or equal to 10, then do this, or else, I'm just gonna do or else, then, oh, I'm messing that up. Or else, then set the power to 0, right? Now let's just run through this really quick so that we know that's right. Oh, I'm running low on time, so I'm just gonna do this quickly. So okay, first loop cycle. If the timer is the timer less than or equal to 10? No, it's equal to, or yes, it's equal to 1. So I'm gonna set the power to 1. Is the power, let's say that the timer is equal to 10. Is it less than or equal to 10? Yes, it is equal to 10. So then I'm gonna set the power to 1.0. Is the power, okay, so let's say that the timer is 11. Is the timer less than or equal to 10? No, it is not, it's 11. So then I'm going to go into this or else section. And that's a good example of how the conditional works, and Nihar is going to go into the code for that.
Mm-hmm. So here, let me present my screen again. So basically in a nutshell, the code to drive for 10 seconds would be if the timer has not reached 10 seconds, then set a certain power to the motors. If it's gone past the 10 seconds, then set the power to 0. And power in FTC just means it's just a percentage of the maximum like rotations per minute you're able to go. And it's a percentage or decimal from 1 or 0 to 1. Or actually, no, from -1 to 1. And -1 means you're going backwards. Or if you're a negative percentage or a negative decimal, then you're going to be going backwards. If you're a positive, then you're going to be going forwards. And for example, like 0.1 will be it'll be really slow. The
Oh, wait,
rotations will
sorry.
be pretty slow.
Power goes from 0 to 1. Continue.
Wait, really? My bad.
No, the power in FTC, when you say set power, you have to go 0 to 1 only. You cannot exceed 1.
Well, what about like negative on joystick?
Oh, yeah, that's what negative 1 to 1. My bad.
Yeah,
my bad.
-1 to 1.
Yeah, sorry.
Negative means you're going backwards. Positive means you're going forwards. And yeah, so timer.time. Yeah, so so this is returning something, right? So let's just do double current. Actually, let's create that as a variable above. So let's call that here, let me just comment this and say variable. Okay, and then let's create a variable called, or let's say this, creating a new elapsed time timer. And then below that, we'll create another variable, and we'll call this, or let's say that we're creating a variable for current time, and we'll do double current time. We'll set that to 0 currently, because that's just an initial value we'll set it at. And you can do this as well you can do something like this and set it to, this is another way to set something to null. It's just not literally having nothing on the equal sign or an equal sign, and there's nothing there, so it's set to nothing. And you can actually do current time equals 0. So yeah, we'll just do this as a better way to show you how the init works. We're setting current time equal to 0 once, and that's during the init period. Now let's store this timer.time. So again, this is a return method, correct? So it's going to return the current time, and we're going to store it in this variable called current time. And this will be looping through, and current time will be updating every single time. Like I mentioned before, you can override variables, so you can change the values throughout the program. And at one point it's 0, but then as we go on, the time will increase.
Okay, we have a question. So double is a data type. So Nihar, do you still have the slides up?
Yes.
Somebody's asking what double means. So if you want to explain that really quick.
So a double, again, it's a data type, right? So data types can come in different types. So they could be int, float, characters, booleans, and strings. There's also doubles. So double is a decimal number. Examples are 1.0, 0.5, 0.75, and they're basically just huge decimal numbers. They can be huge decimal numbers. They can be small ones too, or they can be really large. So how we set a decimal variable is we have this, this should actually be 0.0. That's a better way to put it, because we want to make sure that Java knows that it's a double and a decimal type by adding this decimal place right here, or this decimal and then 0. So that is a decimal, or that is a double. Does that make sense? All right, cool. So yeah, so a double is just a decimal. And so we're returning the data in this method to current time. So current time will be continuously updated. and yeah, it'll be set to the current time. So now what we can do is create an if statement. So if current time is less than or equal to less than or equal to 10.0, and then we'll use these two parentheses. And since there's nothing in this code block, so it's going to do nothing currently if the time is less than or equal to 10, let's copy this code to set power. And we'll put it in this code block right here. So currently what is happening right now is if the current time is less than 10, then it is going, or less than or equal to 10, it will set power to the motors. But what will happen if it's not set to 10, or if the time is greater than 10? Currently it's going to do nothing, and basically what will happen is the motors will pretty much just ramp down like really slowly because there's going to be no power. But a better way to do that is just set the power to 0. It's basically just breaking the motors. It's setting it to 0 power. So in this same if block, you can do something called an else.
Yeah, I also wanted to say that if you don't set it to anything, then it's actually like when you say set power, that means set power
it'll always be set.
So if you don't set it, then it's actually going to keep running at the same power. So it's going to keep running infinitely, and most likely, that's probably not good because you're basically telling your robot to stop, but it's going to keep going on, and you're probably going to break something. So yeah, just make sure that you don't mess that up.
Yes. So now what you can do is something called an else, and it's basically saying what else happens if this condition has not been met. And remember, this is still part of the if statement. It's still part of this if block. You can do it like this as well, but let's just keep it. Oops. Keep it right here. And else, what happens? So the other situation, if it's greater than 10 seconds, then you can do left motor, set power, and set it to 0. Right motor dot set power and set that to 0. So there's one step that we actually forgot to do, and we actually need to do something called reversing the motors. Ishan, do you want to talk about that? Why do we reverse the motor, one of the motors?
Wait, should we talk about that during the mechanism drive lesson, or should we just do that now? Oh wait, no, that's needed. Yeah, regardless.
We need to do that.
So the thing is that your motors are actually, well, most likely inverted. So if you built your robot like, well, most people build their robot like this, but they put 2 motors and then they're being powered. But the problem is that they're in opposite directions. They're going in opposite directions. So the way that we do that is we reverse one of them, because currently the robot thinks that they're going in the same direction. So if you set 1.0 to one of them, it'll go this way. And if you set 1.0 to another one, it'll go this way. So all you have to do is reverse one of the motors so that they're both going the same direction, physically at least. So yeah. So the way that we will
wait, Ishan, let me just pull up a drivetrain really quickly in one of our presentations. So as you can see, the actual shaft of the motors are on different sides. So the left, so this is back left, the shaft is on this side, and back right, the shaft is on this side. So the right motors will be going in one direction, and the left motors will be going in another direction. So.
Okay, so we're actually over time right now. So if you need to leave, you can. I think I think Nihar's like finishing up really quick. So, Nihar, how long do you think this will take? Or are we almost done?
Yeah, we're almost done. This is pretty much it. So
okay, so that's how you reverse it. You just do left motor, or the motor name, the variable name, dot set direction, and then DC motor simple dot direction dot reverse. It's
Yep,
just it's like, I know it's complicated, but it's just something that, I mean, I guess you can either memorize, or there's also online examples on how to reverse motors. So if you ever are
Yeah.
stuck, forget how
Mhm.
forget all that syntax, just go online and just say FTC reversing motors. There's a ton of documentation, and even the example code has it. So we're actually running low on time. So I think, yeah.
Yeah, so just one last thing, like if you guys want to know more about like the different methods that these motors or these objects or variables have that FTC allows you to use, you can use something called documentation. And documentation is really important in programming and in software development. Like every programmer needs to look at some sort of documentation so they can understand how to use the code. And for FTC, you would look up the SDK Java documentation, and that would just outline like all of the different classes that you can use. So like the DC motor class, it will tell you all of the different methods that you can use, all of the different like variables you can use, like all of that different stuff. And similarly to how we showed you guys the we gave you a couple methods that will be commonly used. It will basically be like this, except it will you know, there'll just be a ton of different methods, and it'll give more descriptions about them that you can actually use. So yep, that's pretty much it. I hope you guys were able to learn something from today's lesson about the FTC SDK. If you have any questions, comments, or concerns, please email me. You probably received emails from me from the weekend, or you can check it out on the virtual hub document. My email's there as well. Besides that, you guys are you feel free to leave. So
Thanks a lot for this. I guess I'll see you guys in the next few days.
yep. So just remember we have class tomorrow, Wednesday, and Friday.
Yep.
Mm-hmm. All right, cool.
Have a nice evening, I guess.
Yeah, you too, guys.
Yeah, good work today.
And also, we're gonna post the recordings
Yeah,
and the slideshow in the hub. The
Yeah, so
presentation's already there, so you guys
mhm.
the recording.
So once I stop this recording, it'll save to my like computer, and then I'll upload it, and then I'll update you guys tonight sometime,
Oh
and you
yeah,
guys can
are you
access
guys
it.
are you guys all fine if we upload this video on YouTube?
Yeah, we already said that before, I think. I
Was
already asked.
everyone here on the call?
I think
Yeah,
Okay.
everyone looks pretty cool with
Yeah,
it.
I'll post it around you.
All right, cool. Bye. I
Yeah.
think we're done.
Bye.
And see you guys.
See you
Thank
guys.
you for coming.
Bye.